Okay, yeah. Hello, welcome everybody. My name is Michels. And yeah, I want to talk about navigation systems or challenges of navigation systems to assist blind and visually impaired people in planning and finally finding their way. So it's called Going the Safe Way, providing safe and barrier-free pedestrian navigation. And yeah, it's more talk about the challenges, the problems, less about the solutions. About the solutions we can also talk later if you want. Okay, let's start with an example. Did you or have you ever been ambling along the Kudamm or the Friedrichstraße? So Berlin offers a lot of nice places. I think you know, I know, like the Friedrichstraße, to enjoy, have a walk there, go shopping and so on. And now try to imagine to pass all these places, the ways, with your eyes closed. So can you imagine what will happen? I can, because we tested it, and it can become really dangerous. So for example, normal street furniture, like the lights, the traffic lights, and some bollards, and so on, are now obstacles which are potentially risky for you, right? And you need information about it. Another example, can you remember how you came here? So the last mile, the footpath to this building here. And this is an example calculated with Grasshopper on OSM data. We have here the underground station, and on the top you have the building here. And yeah, it's not the nearest underground station, but it's also a problem in Berlin to find the right exit, right? Which is nearest to your final destination. So let's assume we start here, and let's check now how the way looks like in reality. So we have here one Google Street View picture, and the first interesting topic is crossing a street. So what do I have to know to cross a street? I have to know that there is a traffic light, and it would be nice to know if this is a traffic light for blinds, or if the traffic light has a push button, right? I have to activate it. If I don't know it, I stand there a long time. The traffic light also has another function. It's an obstacle because it's directly in the middle of the way. And maybe I need also information about the curbs, so the border between the street and the sidewalk. And here you have also an example for an island between the streets. I need the information that there is one, right? That I can stop there. Another example, if we follow the calculated way, we have to here move, we come from the right and have to move right. So what's this? What the hell? An obstacle, yeah, which can become really dangerous if you try to take the way without seeing anything. So let's assume the person is not going this way and is going straight on. Finally, you arrive at this situation here, coming from the right again. And also at this place, I think it would be really nice to have the information that there are some bollards and that there is a vehicle exit so that vehicles can cross my way. Okay, that's the project behind this. M4Guide, it is called. On the bottom you see all the partners. It's a bigger project, and yeah, I called it now Safe Routes for Blind and Visually Impaired People. And I gave you only examples about the outdoor environment. M4Guide is a door-to-door project, so which means we have to assist the blind and visually impaired people for the entire way. So starting at the home, using public transport, and also going through the buildings, especially if you go to the underground. So having information about the obstacles at the underground station, and also to know if you are in the right bus and when do I have to get out of the bus, right? So we have three contexts: outdoor, indoor, public transport. Today I only want to talk about the outdoor problems, or the problems or the challenges we face in the outdoor environment. If you need more information, you can contact me and I can forward your contacts or something like this. Okay, and yeah, why IVU? IVU Traffic Technologies, that's the company I'm working for, and we are part of the project. The main business, briefly, is the public transport, so providing software solutions here for planning, disposition, but also operation. One interesting Beispiel, not here in Berlin, it's in London, so the passenger info for all the buses and stops there, and also private transport, now or today an interesting topic, and also here we have a solution for the post bus. I'm working in the department which is a bit smaller and deals with location intelligence. And here, our main focus or the main topics are on the one side, location analysis, finding the best location for your suits. So planning, in this case, Deutsche Post planning a bunch of offices, or the media planning. So of Einkauf aktuell, that's a bunch or a bundle of advertisements, and they want to optimize the distribution of it, right? And on the other side, the second topic is tour optimization, especially on demand, in the use case of express services. Okay, but that's it. Back to topic. In the headline you have the safe way, going the safe way, but you have to decide what is a safe way, and of course this is somehow application orientated, or it depends more on your community. A common definition, it was in German, I hope I translated it correctly. A state in which you feel well protected against hazard or harm. Also here, it's a feeling, right? So it depends always on the persons or on the community. And to bridge the gap between this final state and the data you have, you have some factors, or you define some safety factors. In our case, so navigation for blind and visually impaired people. For example, you can use highly frequented roads, right? Crossing highly frequented roads is one safety factor. Or another one are passing obstacles. So that is common, that's general for the whole community. But there are also, these safety factors also depend on personal sense. An example is the width of the footway. Someone who uses a blind man's stick has no problems with a narrow footpath, right? Because he is able, using the stick and finding the border on the left and on the right and pass the way. Someone who is using a guide dog has a problem with narrow ways, because the dog is going next to the person, and if you have then some lights or some other obstacles, it can become really tricky to pass a small or narrow way. So it's pretty customized, and yeah, the final output is here, right? Safest route is mostly not the shortest route. So we have other factors here. Let's assume we have a route, a safe route now. What comes next? Now you have to guide along the route. And it's obvious, of course, that you have to provide more information than normal navigation systems, but you have less channels, right? The complete visual channel is not usable, so you can't use maps and show on maps and talk about maps. So finally, we identified the biggest challenge is the balance of amount of information, because we provide here, in this case, the information via speech, and it's really tricky to find a balance. So provide not too much information, because this can be annoying or tricky if the person has to concentrate on the traffic, for example. Also, don't provide too less information and leave the person alone. It's also hard. And yeah, finally, you have to end up like inform just about the ticket at the right time and the proper place. So you have to decide, what do I have to tell and what not? When do I have to do it? And of course, where? That are the big questions. The fourth question, of course, is how. It's also an interesting topic, human-computer interaction. How do I provide the information at its best? But is not part of the project and also not part of this presentation. So don't wonder. Okay, to assist blind and visually impaired people, in the outdoor environment we have 4 modules, let's say. First is navigation, of course. That's the final product which is used by the end user. And I picked out only 2 interesting topics, what is required. First, a kind of preview. Blind people need a really detailed preview of the entire way, so that they are able to inform about the way before they start, and also identify critical situations and maybe also dangerous parts of the way. So that is something which is standard. You have a list of waypoints with actions in it, right? You have to turn right, you have to cross this and this street, and so on. And from this, you need a text, a complete text, which can be spoken via the device to the blind. So this is one interesting topic. The other one is the deviation, calculation of deviation. And here are 4 types of deviation. On the right side, that is a spatial deviation that is standard for all the navigation systems. So recognizing when someone leaves the route, is not on the route, and then to decide either please go back or recalculate the route, right? There are different let's say thresholds when to do what. Of course, we had to also implement this, but that's more standard. On the left side, we have something which is required in this application. It's first time deviation. We are in an intermodal context, so the person is going to reach a bus or the subway or something like this. So time is a critical point, and we have to provide him with information about is the bus reachable or not, and how to react if it is not. So maybe he needs another vehicle, so it's changed to the subway. The other one, and which is also really tricky in reality, is the deviation of direction. So we have to give some information about orientation. So the blind people have to know where to go, especially when they start somewhere. And of course, if you have small curves like this, you have to tell somehow. Second one is positioning. It's not part of our work. I only briefly talk about it. You need high, precise positioning to provide or to assist blind people. For example, of course, you want to know or you want to tell on which side of the street the person is, right? And you want to tell them in 5 meters there's an obstacle, pay attention on it. If the GPS or the positioning in common is 10 meters behind you, right? You fail in telling him that there is an obstacle. And another one is, of course, what do you do when your position is on the footpath, but the device tells you, hey, no, you're here at this position, and the accuracy is pretty good. That's why the bullet is green. How do you react on this? And here I can tell you, only using GPS or GNSS is or doesn't fit the needs within the cities, because the accuracy is not good enough. You need further solutions. Routing, I talked about it. You have to provide customized and application-specific routing. Here we work together with the people, talked about and defined profiles at first. So we have, I think, around 40 or 50 parameters, which have, each parameter has its own weighting, and the weighting influences the route, right? And we discussed which parameter should we have one weighting, which weighting, yeah. And the second one is, of course, the customization. So at the end, you use your profile. Let's say I'm visually impaired, I use the profile, but I want to customize it during the request. Okay, and last one, most important, I would say, data. No service without data. And of course, if you want to have high accurate navigation, you need high accurate data. So you have to know that there is the foot path, that there is an exit for vehicles, and you have to know all the information about the crossing there. Here, this is the situation in the data model. So we looked from me to the crossing. And finally, in this project, we were pretty lucky because in the preparation phase, it was defined that we collect the data in a test environment and collect all the important information for the blind people. So at the crossing line there, or at the line representing the crossing, we have the information that there's a traffic light. We have the information that there's an island between the streets. We have a paved surface there, and also pretty important is that you have tactile indicators for the crossing. That's everything in it. And this is something you need to use it in the routing engine, right? And of course, to use it in the navigation to finally provide the information. Okay, that's it. The last slides, the bottom line is that, or what you should take with you if you are interested in this topic. You need highly accurate data, flexible and personalized routing, and high precision positioning to finally inform just about the ticket at the right time and at the proper place. The project is in an end phase now. The testing phase is starting now, and we will learn a lot, I think, and maybe we can't have for everything a solution, but we can improve the situation for the blinds. And that is something we learned until now. I also picked, again, only 3 points out of it. The first one, less is more. I said it at the beginning that if you talk too much, right, to the person is annoyed and can't concentrate on the different things which are important now at the situation. The second point is the more information you provide, the more wrong information you provide. And it is really, really tricky to filter out which information my device currently or the algorithm currently produced is wrong and which information I don't or I can't provide to the end user. So pretty hard. Then the semantics problem, half left is precisely not half left. So we had first tests, and of course you have to find another solution than saying now turn half left, because it's different. And the last one is a summary. The world is complex place. It is. Each time we went out and test the software or parts of it, we had situations, conditions in the road network where we were not able to guide through this situation, which is usable for a blind or visually impaired person. So, especially here in Berlin. Okay, last 2 slides. Only what we've developed, that is only one point, called Evo Navigation, because that's new for us. We built a component, and interesting here is that it's a component you can use in the background. You have an API, and the nice thing is that you can decide on your own, if you integrate it, what information I want to provide, what not, and how I want to provide it. Of course, you can also provide all the information on the map. That's also possible. And that are the systems where it is currently integrated or very integrated now. On the left side, the research projects, Forgat and Dynamo. And on the right side, of course, we have an own prototype to test all the functionality, and Evo Workforce Mobile is one of our products. And on the back end, on the server side, currently we have the routing engine connected, and next steps would be, or it would be nice also to connect our geo service, the other geo services for geocoding and map representation. And finally, that's always an interesting topic in research project, what happens after, what happens to all the solutions of the project. Here again, we are really lucky. We have as partners the VWB, BVG in the project, which are the service provider for public transport here in Berlin. And they have a journey planner called FahrInfo. And within the FahrInfo, we provide the last mile routing, so the routing for the pedestrians. And this is the concept, or this is how we want to integrate it in the next year. We have a component also developed in a research project called eFootrouting Proxy, which is able to decide, depending on the vehicle or profile of the request, which road network or which graph is to use or has to be used. And that is pretty important because they have an infrastructure, they have OSM data, and this works really fine, and they don't want to leave it out. So we have to add only a new graph on another server, and the software should decide who is provided with which information. Okay, that's it. Thank you very much for your attention.